So traffic modelling is essentially a computer model, a mathematical model that we use to predict people's trip patterns and travel choices so that we understand the uses of roads and public transport on the network.
We start by collecting a lot of data. We need to understand where people live, where they work, where they shop, and therefore how they travel. This data comes from a number of sources. We collect information from VicRoads, such as traffic counts, and new technologies such as Bluetooth. PTV provides us with passenger information, and the Australian Bureau of Statistics provides us with population, employment and school enrolment information.
So we look at four main ways that we use this information within the modelling. The number of trips, how many trips people make, where they go to and from, what mode they take, if they're taking public transport or car, and which route they then take. We do a number of what-if scenarios that we use within the modelling. So we change things such as population, we change employment, and we change other cost factors as well. We go out as far as 2051, but we do intermediate years as well, such as 2026 and 2036 as well. To find out more, visit our website, northeastlink.vic.gov.au.
Authorised by Victorian Government, 1 Treasury Place, Melbourne.
People everywhere are responsible for creating greenhouse gas emissions, the cause of climate change. But we differ place to place in the amount we create and the sources that create them. Here in Washington State, we are responsible for 100 million metric tons of greenhouse gases annually. That's of the nearly 6 billion metric tons of total emissions released in the United States each year. In most states, coal burned to generate electricity is the main source. But in Washington, most of our electricity is generated by hydroelectric dams. Also, the amount of miles driven per household is greater here than the United States average. That's why the most recent climate assessment by the Department of Ecology shows transportation as our #1 source of global warming emissions. And if you just look at transportation, the majority of that comes from gasoline burned in cars. This is one of the reasons why reducing our carbon footprint will depend on the choices we make planning for our communities. Decreasing our dependence on automobiles is our region's greatest opportunity for reducing our contribution of carbon emissions. But it's not just about making choices to change transportation habits. It's about land use, the way our communities are planned and built. It's important to understand that transportation and land use are inseparably linked. The places we live are the biggest indicator of how we'll choose to get around. Here's an example. To choose to walk to the store instead of drive, you need more than good sidewalks. You need somewhere close enough to walk to. For most Americans, 1/4 of a mile is the distance they're willing to walk for utility trips, like shopping. So the more places you can walk to within 1/4 of a mile, the greater the opportunity you have to walk to places you need to go. The quality and efficiency of public transit service is also dependent on land use. You're more likely to take the bus if it comes every 15 minutes and goes right to where you're headed. But 15-minute bus service only makes economic sense on routes that have a good mix of housing, jobs, and services at sufficient densities. Neighborhoods that average 10 housing units per acre, mixed with commercial areas with 12 employees per acre, are typically the minimum amount needed for transit-supportive neighborhoods. But even in dense urban areas, most people will continue to rely on driving for most of their travel needs. How far they have to drive and how efficiently they can travel is directly related to land use and how communities grow. Connected streets and designing buildings and streets with multiple transportation choices in mind will help make travel more efficient, with lower out-of-pocket costs for everyone. But how do we know this type of development is more efficient? Here's an example. A recent study combined total residential energy use from buildings and transportation from all across North America and combined each fuel measurement into one hard number, millions of BTUs per year. Using a common measure, it's easy to compare different types of energy. First, let's look at a single-family detached home in a conventional suburban development. The darker area at the top indicates the transportation energy used, while the lighter area at the bottom is building energy use. Now compare how much energy could be saved by using green, fuel-efficient vehicles, again, the darker part at the top of the bar, and green energy-saving building methods, indicated at the bottom of the bar. Now let's see the difference if we build similar homes in a transit-oriented neighborhood. Notice that building energy use in each bar did not change, but the top part shrinks because residents require much less energy to get around. Given the same scenario, but in single-family attached buildings, each building uses less energy because attached units are generally smaller and use less heating and cooling. Finally, let's look at a multifamily residence. Again, you see additional building energy savings because multifamily housing is inherently more efficient due to its compact nature. Here's an interesting point to be taken from this study. A household could live in a multifamily residence in a transit-oriented neighborhood and not take any steps toward reducing home energy use or go green, and they would, on average, use less energy in a year than a family who is taking steps to go green in any other type of development. In most cases, compact transit-oriented development automatically uses the least energy per person. And that's important to keep in mind, because we're not just planning for the people you see on the streets today. With Thurston County's prime location and high quality of life, we're expected to attract 170,000 new residents over the next 30 years. Let's look at a couple of options to consider how this growth could look. We're expecting 60,000 new homes in our urban area to accommodate future growth. If all those homes were conventional suburban development, it would fill the 97 square miles encompassed by every city and urban growth boundary in the region. The roads built to accommodate that kind of development would cause major traffic on rural roads and would make walking, biking, and transit unlikely or impossible for many of these new communities, causing long, frustrating commutes and high costs for pocketbooks as well as the environment. If those 60,000 homes were all built in mixed-use, transit-oriented communities at the minimum density to support efficient transit, they could all be done on our urban corridors in the existing urban areas. This would enable more of the current residents to expand their travel options, reducing everyone's car dependence and the related travel expenses and carbon emissions that go along with it. Of course, the reality will be somewhere in between these two options, with a variety of densities in different places. The direction we head will be determined by the policy and land use priorities we set now, along with the market demand that drives housing and commercial development. The tools we have to shape our future are those that Thurston County communities have used to plan over the last 20 years of growth. The countywide planning policies, local comprehensive plans, and the regional transportation plan. By articulating the vision reflected in these plans, and by leveraging cooperation between jurisdictions, developers, and community groups, we have the opportunity to encourage walkable and transit-oriented neighborhoods, manage I-5 capacity, coordinate with regional partners like Joint Base Lewis-McChord, agree on meaningful metrics for evaluating success and meeting goals, and much, much more. Think globally, act locally, plan regionally.